Hello everyone, I am Sachin and today we are going to learn about what are the self-organizing maps and how they learn and finally a real-world application or the dataset for self-organizing maps. So if you look at its definition, it is also called as the Cohen map because it was developed by the Finnish scientist Cohen, and it is the unsupervised neural network technique. The higher dimensional data is reduced into the two-dimensional, but the topological structure remains unchanged. It is type of ANN but uses competitive learning instead of error correction. It is usually used for exploring the data patterns and detecting clusters using variables. A data set with p variables measured in n observations could be represented as clusters of observations with similar values for those p variables. These clusters then could be visualized as 2D map, such as observations in proximal clusters have more similar values than observations in distal structures. The best matching unit BMU is used for that, and the data distance functions and the neighborhood functions are used, such as the Euclidean and cosine functions, and here the Gaussian function might be used. In its first step, the 2D grid is defined, and neurons are associated with weights. Their weights are initialized randomly. Then input vector is selected randomly to find the BMU, that is the best matching unit, where the of course distance formula is used. Here you can see Euclidean distance formula is used. Then weights are updated using this formula, and then by reducing learning rate over the time and ultimately the neighborhood radius, the BMU can be found. And later on it can be visualized with the U matrix or label map. Here is again the training process with some Wikipedia images are shown. You can see the BMU is founded and how the weight adjustment step is there. Here is the real world application of customer segmentation for marketing. Customer data is usually feed into the SOM, and then customer segmentation can be achieved using the SOM. So now we will head towards the visual explanation of how SOM clusters data with real world application on US Congress voting patterns. Here the data of Congress members versus votes, that is yes, no and abstain, are shown. The SOM maps voting patterns on this 2D grid. Plots show clusters for similar voting groups. Darker means greater difference from the neighbor. Red means the predicted Republican Party, and blue is predicted Democrat Party. And others show yes for bills, for red, and no as blue. So the lighter areas signify the smaller distances, with the darker larger distances between the neurons. So the self-organizing map are usually best for as they preserve the topology, and they are effective for visualization as we have seen in the U matrix visualization. Thank you.